So here in this video, we will be looking at the routing process from PC1 and over to PC2, i.e. from the 10 network to the 11 network, going through the router. We will be looking at the IP addresses in the routing, the IP addresses for the PCs and the IP addresses for the gateways. We will also look at the individual devices MAC addresses, PC1 and PC2 MAC addresses, and the router interfaces MAC addresses. How does all this come together in the routing process? When PC1 wants to send data to another network, it will send this packet to the default gateway. In this case, PC1 has a destination it wants to ping over on the 11 network, and it puts its own address as the source address. PC1 actually doesn't send this packet to the default gateway IP, but to the MAC address of the default gateway. So that is the destination MAC address that PC1 will put into the frame here. It will put its own MAC address as the source MAC address. In this way, the frame here will be sent from PC1 MAC address to the gateway MAC address, from source address to destination address. So PC1 sends the frame here over to the router. The router will realize that it has to send this frame out on GE002. So what will happen now is that the router will substitute the MAC addresses with new MAC addresses. The new MAC addresses will be the source address of GE002 and the destination address of PC2. So the frame will now go from GE002 to PC2 from MAC address to MAC address. Note how the IP addresses are untouched. The IP addresses will stay the same through the entire routing process. The router will send the frame down to PC2. PC2 will receive the frame as it is destined for its MAC address, and it will open up the packet and see that the destination address is actually, for me, it's for the PC2 IP address. In this way, we have had physical activity, we have had data link layer activity, the MAC addresses, and we have had IP address activity on the router and on the PCs. So let us look at the process in Wireshark and on the devices. I'll open up Workstation here. I'm in PC1. So let us open Wireshark on both PC1 and PC2 to see the communication between the devices. Here we have Wireshark on PC1. Over on PC2. So we have Wireshark running on both devices now. So we will generate some traffic. I'll ping from PC1 to PC2. I'll set a limit of 3 pings. That's all we need here. And we can see behind the terminal here that the pings have been captured over on our Wireshark. We are currently, the blue marking here is currently on an echo ping request. And that's actually also, if we look over here on the left-hand side, what we expected, we are sending out from PC1 echo ping requests. And we have some source and destination IPs, and we have source and destination MAC addresses here. we can already see up here that the source address and the destination IP address, they correspond to what we expected. So let's now look at the MAC addresses also. If we look down here, you can see at this level here, we have source address and destination address in correspondence with our source and destination MAC addresses over here, namely the source MAC address of our PC1, the DB, and the destination MAC address of our gateway interface, the C5 address here. The frame we have captured here, this frame here, the echo ping request frame, is dissected down here in the dissection area. If we want to relate that to the OSI model, we have at the lowest level, we have the physical layer. The physical layer is what is dissected here, the frame. The data link layer is the next layer, Ethernet 2. It's called over here in the dissection part in Wireshark. The networking layer is the next part. And finally, the transport layer, which is not existing in this case here. The ping program operates directly on the network layer. So the ICMP, Internet Control Message Protocol, is a program, the ping program running directly on the network layer. So transport layer and application layer are not listed here as they are not used in the ping program. Now let us move over to PC2 and see the process that happened over there. So here on PC2, if we look at the IP addresses and MAC addresses, let's select another, this frame here, and look at the MAC addresses and IP addresses. You can already see up here in the listing here that we have the source IP address and the destination IP address. They are the same as they were before. You can mark that over here. It's the source address of PC1 and the destination IP address of PC2. So nothing changed here. This is what I have shown over here. This here is the frame arriving at PC2. I have cheated a little bit because I have changed the source and destination MAC addresses. But this change, as we saw before, of the MAC addresses was actually done up here by the router at layer 2, changing the MAC addresses. If we want to relate this to the OSI model, we have the networking layer with the IP addresses there, and we have the data link layer with the MAC addresses right here, the dissection of that. The physical layer is the first part here, which you very rarely will have to look into. The ICMP protocol is working right on the networking layer, so that is why we don't see any transport layer information or any application layer information, which would have been over here, this part here, but there's nothing because ping operates at the networking layer. So we can see here in Wireshark that the IP addresses, they were unaltered, source address and destination address from 10.2 to 11.2. But the MAC addresses at the data link layer here, they were changed. It is now the MAC address of PC2 as destination and the source address of our gateway as source address. So the MAC addresses were switched by our router, and our frame here, the last part of the journey, was from the gateway to PC2, based on the MAC addresses. How did PC1 know the MAC address of the gateway? How did the router know the MAC address of PC2? And for that sake, vice versa, how did PC2 know the MAC address of its gateway? And how did the router know the MAC address of PC1? Let me clear all this. It is the ARP process responsible for resolving IP addresses and MAC addresses. So if here on PC1 we take a look at the ARP table. So it says here gateway and MAC address. If we run the ARP without name resolution, we can actually see that the gateway is, as expected, 10.1, and of course it's the same MAC address. So the ARP process has been working behind the scenes for, it has resolved the gateway IP address into this hardware address or MAC address, as also indicated over here. And it is you who have set the gateway here, the 192.168.10.1. Likewise, over on PC2, we can also look at the ARP table. And again, we can see here that the gateway is rightly 11.1, and the hardware address or MAC address is, as I have also indicated up here, for G002 or 11.1 IP address is 66 MAC address. But what about the router? How does the router know the MAC addresses of PC1 and PC2? Let me clear this. We will go to the router. I have PuTTY running, so I'll open PuTTY, which is my router over here. I have exited edit mode by typing exit, and here I can run the ARP command. And here we can actually see that the ARP process running on the router has learned two IP addresses, MAC addresses, namely our 10.2 and our 11.2, i.e. PC1 and PC2. The ARP process has been working on, from the router, rightly the MAC addresses of respectively PC1 and PC2 there. In this way, all devices here, PC1, PC2, and the router, they all know each other's MAC addresses, and based on the IP addresses, they are able to send data to each other. The router will switch the MAC addresses accordingly, and the IP destination address will guide frame through the network. This is routing. We can also monitor the ARP process from the router in Wireshark here on PC1. We look at the frames over here. These two here. This is the router. Please tell 10.1, which we have over here. 10.1 is G001 interface. Please tell 10.1 who has 10.2, which we know is our PC1 down here. And the reply is coming right here. PC1 with its 10.2 address says, I am or is at this MAC address. And if we look over here at our drawing, this is indeed our MAC address. So this was how the router's ARP table was populated out on G001 for PC1 at 10.2. That is how the router got the MAC address. It was the ARP protocol responsible for the router learning the MAC address of PC1. If we want to relate the ARP process to the OSI model, we always have the physical layer, which we normally do not look at actually. So let's go to the data link layer. This is where we have the MAC addresses. And what we can see here is at the data link layer is that this was a broadcast. So all devices in the broadcast area out on GE002 would look at this frame, check what was inside the packet, what to do. In this case, it was an ARP only for PC1. The source MAC address is the source MAC address as indicated over here of G001. And we can learn here from Wireshark that the address resolution protocol is running right on the data link layer. We have it there, address resolution protocol.